Hello, hi students. This is me, Vinoth. Today we are going to see another problem from the chapter Real Numbers. This question has been taken from the textbook of 10th Standard Mathematics by R.D. Sharma, sir. Exercise 1.1, and the question number is 14. The question is, show that one and only one out of n plus 4, n plus 8, n plus 12, and n plus 16 is divisible by 5 where n is any positive integer. As per our previous questions, we have to take it here. N as they said n is any positive integer. So we can write the solution as we start that. It is said that n is any positive integer. So we can say uh, since n is any positive integer, it is of the form, we can say it is of the form, it is of the form phi q. We are taking that format of instead of 5 into q because here it is that it's divisible by 5, so we have to take the divisor as 5. So phi q, next one is phi q plus 1 or phi q plus 2 or phi q plus 3 or phi q plus 4. So we have assigned that this we have written the format of n. Now we have to prove that only one of among these values is divisible by 5. We have to assign the n values as each values for n. Now we have case 1. In case 1 is when n is equal to phi q. So we have taken phi q as that case 1, such that we have such 5 cases are there. We have to write 5 cases. The first case, case 1, is when n is equal to 5. Okay. So if n is equal to phi q, so if n is phi q, which is divisible by 5. Why it is because it is n, it is written as 5 into 5 into q, where q is some integer. We can write where q is some integer. So 5 is also integer, q is also, it is a right, 5 is one of the factors, so this number is divisible by 5. There is no problem in that. Now we can take it, n value is phi q again. This time we have to check it for n plus 4. So n plus 4 is equal to phi q plus 4. So plus 4 we have given. What is 4 here? Plus 4 is a remainder, right? In the format of by Euclid division lemma, 5 is a divisor, q is a quotient, plus 4 is the remainder. So it is reading remainder 5. If a number should be divisible by 5, it should end with 0 or 5. So we have the remainder here as one of the factor, and we have remainder 4. This definitely, this number is not divisible by 5. So we can say that n plus 4 leaves the remainder, leaves remainder 4 when we divide, when divided by 5. So definitely it leaves a remainder 4. So we can conclude there that for we can say that n plus 4 is not divisible by 5. Now again, we can take n value as 5q for the next case, n plus for we have to prove that n plus 8 is not only any one of among these is divisible by 8. So we have taken this n plus 8, we have substituted n value as 5q. Further, this way we can write as 5q plus 5 plus 3. We can write this as 5 plus 3, which is equal to, we can take 5 common outside. So 5 into q plus 1 plus 3. So here remainder is 3. So n plus 8, when we it leaves a remainder, which means that it leaves a remainder when we divide by 5. So it leaves a remainder 3. So it leaves a remainder 3 when we divide by 5. So n plus 8 is not divisible by 5. Now again, we take it for n plus 12. N is equal to 5q for n plus 12. We substitute the value of n here as 5q plus 12. So we can write this again as 5q plus 10 plus 2. So because 10 is divisible by 5. Further, we can write as 5 as common if you take it as q plus 2 plus 2. Now the remainder is, it leaves a remainder 2. Okay, plus 2 is remainder. So n plus 2 leaves remainder 2 when divided by 5. So leaves a remainder, so it is not divisible by 5. Again, we take it as n is equal to 5q, this time for n plus 16. So we can write 5q plus 16. We can write as 5q plus 15 plus 1. We can take 15 as a what is that, multiple of 5. So we can write 5q q plus 3 plus 1. So plus 1 is the remainder here, so we can take it as, so n plus 16 leaves a remainder 1 when divisible by 5. So it is leaves a remainder, so it is not divisible by 5. So if you see entire thing, all others are not divisible by 5. Only the first, when we take n is equal to 5q, that is divisible by 5. Similarly, we have to write for other values also. So for other values means for other forms, for 5q plus 1, for 5q plus 2. So this will be case 2, n is equal to 5q plus 1. The case 3 is n is equal to 5, when n is equal to 5q plus 2. Case 4 is equal to, case 4 when n is equal to 5q plus 3. Case 5 when n is equal to 5q plus 4. Like that, we have to write off 4 more cases in the similar pattern. So you can continue and write the answer. I'm leaving you for as an exercise or a practice to continue it, to complete the answer. You can copy this and you can complete the answer. So students, remember that the answer is not completed. We have written only one case. The 4 more cases are remaining to complete the answer. So thank you for watching. I hope you understood.